Okay, so you are starting with our first question on series and what sequence. So question 1. A manufacturer produces 1,200 computers each week. After week 1, he increases production by. The manufacturer was given two schemes, either scheme 1 and scheme 2. So under scheme 1, he increases production by what? 80 computers each week. Then under scheme 2, he increases it by what? 5% each week. Now with the A part of the question, let's group into I and II. So AI, find the output in week 20 under each what scheme. Meaning that with scheme 1 and scheme 2, let's find the output in week what? 20 under what? Each scheme. I go. So meaning scheme 1 and scheme 2, you are finding output in week what? 20. Okay. II, find the total output over the first 20 weeks under each scheme. Meaning that with scheme 1 and scheme 2, we are finding what? Total output. That's the main what? Understanding. Now with the B part, calculate for scheme. So you calculate for schemes I and what? II. The week in which the production first exceeds 8,000. I got. So now let's start the question. Let's start solving. We have the solution. Okay. So a manufacturer produces 1,200 computers each week. After week 1, he increases production by what? We're giving scheme 1 and scheme 2. So now let me deduce the information from this side so that you get a good understanding. A manufacturer produces 1,200 computers. The manufacturer is going to produce this number of computers as of now. I got. So this becomes our first thing. So we have this. First term is denoted by the letter what? A. So first term is 1,200. Okay. Each week, after week 1, he increases production by what? Scheme I is what? 80 computers each week. So meaning we have common difference. So let me do it this way. So common difference is denoted by the letter what? D. It's given as what? 80. One might ask, how would you be able to identify that? This is my common difference, or this is my common ratio. In our previous video, I explained that when it's given to you in percentages, you are definitely going to get what? Ratios. And with the ratios, it's only the what? Geometric progression where we have what? The common ratio. So meaning that with the scheme 2, which is the 5%, we are going to use the 5% to calculate for what? Geometric what? Progression. Now, this is just a mere what? Question. 80 computers each week. So we are going to use this to calculate for what? Arithmetic what? Progression. That's the understanding. This is ratio. This is what? A number. I got. So this is for what? This is for arithmetic progression. And this is the one with the percentage is for what? Geometric what? Progression. That's all. That's all they need. I got. So from there you can move on to the calculation. Now common difference is 80. Common ratio. 5% is what? Geometric. So common ratio. Is denoted by the letter R. Common ratio is what? 5%. Now remember, it's what? In percentage. I got. Since the common ratio is given in percentage, we have the understanding that normal percentage is what? 100%. I got. And we're giving what? The common ratio as what? 5%. So now, total percentage is what? 100%. And we're given a common ratio of what? 5%. So what we do is we add up this 5% to the 100%. So plus. So we are going to get total of what? The ratio. We are going to get 100 plus 5 is going to give us 105. I go. Now, then we divide this by the total number of percentage, which is what? 100. So we have this 100. So what we get? 105 divided by 100. We have 1.05. So the actual common ratio we are going to use to calculate our geometric progression is what? 1.05 and not what? 5%. Let me explain. Common ratio, we're given 5% in the question. I got. Now, it was given to us in what? Percentage. No, it wasn't 5. Let me name much emphasis. It wasn't 5, it was what? 5%. This was what we were given 5%. Since we were given the number in what percentage, we know our actual percentage was 100%. I got. So now when we're given 5% as our common ratio, so we add up our 5% to the 100%. We now having what? 105. I got. Now we then divide the 105 over the total number of percent, which is what? 100. So we now have what? 1.05. I got. Okay. We have another trick. We will be able to identify that this is going to be my what? Common ratio. Let me teach you that trick as well. So we have, let me do it all. Okay. We're given a common difference of what? 1,200. This is my 1,200. Now I'm going to multiply my 1,200 by the percentage of the scheme 2 that was given to me as my what? Common ratio. 5%. So 1,200 times 5%. What we get? 1,200 times 5. 1,200 times 5%. Let me do it. I'm having 60. I got. Okay. My first term was given to me as 1,200. I multiplied by 5%. I'm getting 60. Now, what I do next is I'll come and add. This is giving me the 5% is giving me the percentage out of the 1,200, which is for 60. Now I want to find the actual total number that was given to what? The manufacturer. I got. So what I do is I'll add the 60 back to the 1,200. So 1,200 plus 60. What am I getting? I'm getting 1,260. Now I want what? The given ratio that the manufacturer is going to use to produce what? The 1,200 was computers. I got. So now the last thing is we now have our total 1,260. I then finally divide it by what? The total number of computers that the manufacturer was what? Using initially, which is what? 1,200. So divided by 1,200. 1,260 divided by 1,200. What am I getting? I'm getting 1.05. So as you guys can see, it's meeting. Using this understanding, we are getting what? The 1.05 as what? Our common was difference. If you are using this understanding too, we are getting what? Our common ratio as what? 1.05. I got. So you can pick any of them. Either you use this understanding to get your common ratio, or you use this understanding to also get your what? Common ratio. Now let's move straight to the question A. Find a total output in week 20 under each what? Scheme. Okay. So I start. This is my AI. Find a total output in week what? 20 under what? Each scheme. Find the output in week 20 under what? Each scheme. Meaning that with the output, you are going to use what? Scheme 1 and what? Scheme 2 for what? Output. Now, when we want to find total output, we are also going to use what? Scheme 1 and what? Scheme 2. So, output. So, let me pick scheme 1. Scheme 1. Okay. Now, 80 computers what? Each week. Remember, 80 computers each week, you are using what? Arithmetic what? Progression. Okay. So, okay. So to find the output, finding out, you have Tn is equal to A plus into bracket n minus 1 D. Okay, we're given what? After week 1, he increases production by what? Scheme 1 and scheme 2. Now the I is telling us to find the output in week 20 under what? Each scheme. So the total number of output is what? 20. So when n is what? 20. So we have this T20. We have this. Our first term A, 1,200. So we have this plus n 20 minus 1. Common difference 80. So we have that. So we have T20. 1,200. 1 minus 20. We are getting 90. 80. Let's see. T20. We have 19 times 80. What are we getting? We have this 1520. So total, let me see, 1520 plus 1200. Marking that's 2720. So with the A, find the output in 20 under what? Each scheme. So the number of outputs for what? 20 is what? 2720 for what? Scheme what? 1. So I'm going to find for the same outputs, but now I'm going to use what? Scheme what? 2. So scheme 2, finding the same what? Output. But with the scheme 2, we're giving in what? Percentage. And I explained to you guys that when it's given in percentage, we are definitely going to get what? A ratio. And with the ratio is what? Geometric progression. I got it. So scheme 2, geometric progression. Yeah. Okay. So the geometric progression, you're also finding what? Output. So finding output 2, we have Tn is equal to Arn minus 1, where R is what? The common what? Ratio. So what's the common ratio? 1.05, 1.05, I go. So R 1.05. First 10, 1200. Number of terms, 20. Okay. So what we do next is we substitute this into what? The equation. So we have T20 is equal to A is 1200, R is 1.05, we have 1.05, N minus 1. So N is 20 minus 1. So we have that. So we have T20, 1200, 1.05, 19. So what we get? Use the calculator. 1200 to bracket 1.05 times 19 or 14. I get 3032.34. Okay. So finding the I, find the output in 20 under each scheme. So finding the output in with 20 under each scheme for the scheme 2, we are getting this I got. So we move on to what? The II. So with the II, to the same understanding, we are going to find total output using what? Scheme 1 and also what? Scheme 2. So I total output. So I'm going to find they said what? Each scheme. So to find the total output for the II, we will find total output using scheme 1 and also find the total output using what? Scheme 2. So let me start with the scheme 1 first. Scheme 1, it's what? Arithmetic progression. So to find the total output using the arithmetic progression for the scheme 1, it's given us. We have Sn is equal to n over 2 to bracket 2a plus into bracket n minus 1. We have our d here. Okay. Now, a is our first thing, was given us 1200. We have this 1200. N was given us what? 20. Output 20. There is what? Common difference, not common ratio. Common difference 80. So we have this 80. So we have x20 is equal to n is 20 over 2. A is 1200 plus n is 20 minus 1. Common difference 80. we have this. So we have x20, 2 goes here, 1 goes here, 10. We have 10 here, we have this, 2 times 1,200. We are getting 2,400 plus 1 minus 20, we are getting 19 times what? 80. So we have that. So we have 2,400 plus 19 times 8. What are you getting? 1520. So we have this 10. So x20 is equal to, we have 10, 2,400 plus 1520. So we are getting 3920. So x20 is equal to 10 times 3920. What are you getting? 39200. So find the total output using scheme 1. We are going to get this. How you got it? Now we are going to find for the same total output, but we are going to use what? Scheme 2, which is what? The geometric progression. We're using what? The common what? Ratio. So scheme 2, we are finding for our total output. The formula is also giving us Sn is equal to A into bracket R exponent n minus 1 all over R minus 1, where A is our first thing, 1,200. R is our common what ratio, 1.05. N is our number of 10, which is 20. So we have S20 is equal to A is 1,200, R is 1.05, N is 20. You have minus, we have this here, minus 1. Okay, that's it. Now we have R minus 1, so R is 1.05 minus 1. So you have x20 is equal to 1,200. Let's do the one in the bracket. 1.05. I'm getting 1.6533 all over 1.05 minus 1. Okay. So we have that 1,200 1.6533 all divided by 1.05 minus 1. What are you getting? This is 0.05. So let's find the final answer. So 1,200 into bracket 1.6533 divided by 0.05. I get in this 39679.2. So that is how we find the total output for scheme 2. Why are we using this formula? We are using this formula because with scheme 2 it was given to us in what? Percentage. Since it was given to us in percentage, we are definitely going to get what? A ratio. And which of the formulas do we use the word ratio? We use ratio for what? Geometric what? Progression. Okay. And we use common difference for arithmetic what? Progression. That's the main reason when we were solving for the scheme 2, we are using what? The total output formula for what? Geometric what? Progression. So now we move on to the B part of the question. The B part of the question states that calculate for schemes I and II the week in which the production first exceeds what? 8,000. The week, meaning that we are calculating for the B part of the question. Calculate for schemes I and II the week in which the production first exceeds what? 8,000. Calculate for schemes I and II the week in which the production first exceeds 8,000. We are going to calculate for scheme I and what's II. So B, we have this. We have scheme I. Every scheme I know falls under what? Arithmetic progression. Okay. How would you be able to identify that with the B part, I'm going to use the total output formula for arithmetic progression, or I'm going to use the normal output formula for what? The arithmetic progression. When you check the B part of the question, calculate for schemes I and II, the week in which the production first exceeds 8,000. There's nothing stated here saying calculate for what? Total what? Output. I go. So meaning we are not going to use for the total output formula. Since it's just a mere question like this, calculate for the schemes I and II, the week in which the production first exceeds 8,000, then we are going to use what? Their what? Output what? Formulas. So scheme I, arithmetic progression, you have this. You have A plus into brackets n minus 1 d. Okay. Where A, our first 10,200. Now n, the number of the nth 10. When you check the question, we are not giving any nth word 10 for the B part of the question. So there is what? A question mark. Okay, D. Common difference. Common difference is 80. So we have this 80. Now, is that in which is it calculate the schemes I and II, the week in which production first exceeds 8,000. So we're giving the total number of output as what? 8,000. So Tn is what? 8,000. So we have 8,000 here. 8,200 plus n. There was no n. Minus 1. Common difference 80. So we have 8,000. 8,000 here. We have 1,200. Now, there's a bracket, there's 80. So 80 times n gives us 80n. 80 times minus 1 is minus 80. We have 80,000 here. Minus 8 when it becomes positive 80. Positive 1,200 when it becomes minus 1,200 is equal to what? This 80n. So we have 80n is equal to, let's go this together, 8,000 plus 8 minus 1,200, 6,880. So 6,880 is equal to 80n. We want to find the nth term. Divide each side or both sides by the coefficient of n, which is what? 80. So we have this 80. We also have this 80. So n is equal to 6880 divided by 8. What are we getting? 86. So we have so calculate for scheme I and II, the week in which production first exceeds what? 8,000. So with the scheme I, the week in which production first exceeds 8,000 is what? 86. So now let's move on to what? Scheme what? 2. So scheme 2. Okay. So scheme 2 is what? Scheme 2. We were using what? Geometric progression. So the output formula for geometric progression, Tn is equal to Arn minus 1. Now we were given total number of output as what? 8,000. So Tn is 8,000. First 10,200. There was no nth term in the question. The nth term was only given in the question when we were calculating for what? The I. The question AI and what? The II. Which was what? The 20. I go. It was stated in the question, the I and the II. But with a B, there was nothing like 20. Or there were no what? Nth term in the question. That's the main reason why with the B part, we are finding for what? The N. I got. Okay. So we have Tn 8,000. Here is 1,200. Now, R. Sorry, let me indicate R. The common ratio, 1.05. Let me put it here, 1.05. So we have that 1.05. There's the n minus 1. There's it. Half this 8,000 is equal to 1,200. Half 1.05. N minus 1. Now, I want to find the n here. I got. But the n is together with this. So I can move this figure to the left hand side. I got. So this is a whole figure. 1.05 n minus 1. So what it does, I would rather divide both sides by what? 1,200. Since this is the coefficient of what's in the bracket. So 1.05 n minus 1 over 1,200. This one to 1,200. 8,000. This moves out. I have this. 8,000 over 1,200. 1.05 n minus 1. So 8,000 divided by 1,200. I'm getting 6.6667 is equal to 1.05 n minus 1. Now here, based on the understanding of either natural logarithm or the principles of what? Logarithm. That's where we apply it. One can decide to either use natural logarithm here or what? The normal what? Logarithm. So what I'm going to do is I'll first use what? The natural logarithm, which is what? The in. When I'm done, I'll also try the same thing with what? The principles of logarithm, I go, which is the log. Then we see if we are going to get what? The same answers. Okay. So using natural logarithm, which is the in. So I'm going to get 6.6667 is equal to, sorry, let me bring it in. So I have in 6.6667 in 1.05 n minus 1. I'm having this. Okay. So now let me clear that side. Now, so we have in into bracket 6.6667 is equal to in, we have 1.05 n minus 1. But now, we are going to get this. I'm continuing from the side. Let me do the arrow so you get it. So we have in 6.6667 is equal to, we're going to get 1.05. But take note, this side is what? To the power n minus 1. So we bring our initial, there's it, n minus 1. So let's do this one first. So let me bring back the in. So that's how we do it. This is exponent, n minus 1. This is in, I go in what? 1.05. This is what? Their exponent. I go. This can be expanded as this. This side is n into by 1.05 exponent n minus 1. I go. This is the exponent of this. I go. But it's not together with the 1.05. So the 1.05 is expanded as this because of the in here. So this is the power n minus 1. Okay. Now I want the n minus 1. So what we do is we divide both sides by what? In into bracket 1.05. So we have this 1.05. This is n minus 1. So we have in 1.05 in 6.6667 over in 1.05 5. So this moves out. You have n minus 1 is equal to, let me do it. Into bracket 6.6667 bracket close divided by into bracket 1.05. We're going to get 38. Sorry, I cleaned it. Into bracket 6.6667 divided by into bracket 1.05. 38.8833. Now I want to find n, so I'm going to maintain n. This is 38.8833 minus 1 when it becomes positive 1. So we have 1 here. So n is equal to this plus 1. What are we getting? We are getting 39.883. So this is how we find for the B part of the question for scheme 2. I got it. This is how we solve for the B part of the question, which is what is scheme 2. Now, for this side we use what? The in. We are getting 39.883. So now let's write it somewhere, and let's also try using what? The log, and see if we are going to get the same answers. So I'm going to the previous one we had, let me put it here, 39.883. So I'm still going to continue from here using what? Log. With the previous one I used what? In. Now I'm going to use what? Log. See if you are going to get the same answer. So now we have log. It's going to be what? Base 10. Because any log has a base of what? 10. So log base 10 is 6.667 is equal to log base 10 1.05 n minus what? 1. Now the understanding of log is this is log 1.05 to the base 10. I got. But we are having another exponent on top of the 1.05. So what we do is we bring this n minus 1 in front of the log. So we now have log 10 6.667 is equal to n minus 1 log 10 1.05. Okay. Now, what are we finding for? We are finding for what? Let me do this here. We are finding for what? The n. I got it. So let me rewrite this here. We have log 10 6.667 is equal to n minus 1 log 1.05 base 10. But what am I looking for? I'm looking for what? N. I got. What to do is I'm going to divide both sides by the coefficient of what? N minus 1. This is together. Sorry, this is together. So I'm going to maintain it. So what I'm going to do is just n minus 1 into brackets log 10 1.05 log 10 1.05. This is log 10 6.667 over log 10 1.05. So I move this out. And now n minus 1 is equal to, let me find for this. So log 10 exponent 6.6667 divided by, so log 10 6.66, sorry, it's 666. Sorry, I made a mistake. It's 666. Don't forget. I hope you guys are not confused. It was 666. So let me correct it. 123. So 1237. 1237. Okay. So let me correct it here so that we don't make mistakes. So 6.667. Okay. I hope you guys are not confused. It was 666. But we made it 1 what? We made it 2 what? 6. So let me do this one. 6667 divided by log 10 exponent 1.05. I'm getting this. That's 8.883. Now I'm finding for what? N. So what I do is I'm going to maintain the N here. This is 38.883. This is negative 1. When it becomes positive 1. So I'm having N is equal to plus 1. What am I getting? 39.883. So it's the same answers. That's it. Using the E, we have 39.883. Using log, we have what? 39.883. So it's the same thing. You can decide to take log of each side here, or you can decide to take what? In of what? Each side here. So any of them is what? Correct. You can decide to use the in, or you can decide to use what? The log and the standard. That's the same thing. So basically with the question 1, that's the format, or that's how we go about when I'm giving a question like this. So we'll see if we can add an additional 2 more questions to it. Then we move towards a different topic.